Hello students, welcome to TSS Tutorial Center, where we make complicated topics to be very simple to understand. In this tutorial we'll talk about questions based on chemical kinetics. So if you never watched the first video for chemical kinetics, then it's better you watch the first video, then you come back to this one. Okay, so let's dive into it. The first example that we have is saying determine the rate law of the following reaction. Okay, so the rate law, it actually depends on the reactant and not the products. So in this case, it's going to be what? So it's going to be rate being equal to K, then the reactant concentration. So we have iron and chlorine dioxide. Now this will be raised to powers. Let's say this one is X and this one is Y. Okay, so let's start by finding the value of X. Is it going to be first order of reaction, second order of reaction, or zero order of reaction? We talked about the order of reaction. For the zero order of reaction, we said whatever happens to the concentration, the rate doesn't change. For the first order of reaction, the exact same thing which is happening to the concentration will be exactly the same thing which will happen to the what? Rate of reaction. When we double, even the rate doubles. But for the second, when we double the concentration, the rate is going to increase by a multiple of 4. We said we're going to be squaring. When we triple, the rate is going to increase by a multiple of 9. When we quadruple, then the rate is going to increase by a multiple of 16. Okay, so don't forget those. I can even answer this question without using any formula. I'll just come here. What do I do first? You're supposed to look for where chlorine dioxide is constant. The concentration is constant, it's not changing. So we can see this one, 0.1, even this one, 0.1, it's constant. Now you're going to use these two positions, that is for this one and this one, to find the order of reaction of iron. Okay, let's talk about iron. The concentration here, it is 0.1, then this one is 0.2, so it has been doubled. It has been multiplied by a multiple of what? 2. They are multiplying by 2 for them to get 0.2. So if the same thing is going to be happening to the rate of reaction, then definitely this is going to be the first order of reaction. We have 1.2 and 2.4. So from 1.2, for them to get 2.4, they multiplied by 2. So they are doubling it. So X is just equal to what? 1. Now, in a case where you want to be using a formula, it's very much important that you also know the formula, but I already know that X is equal to 1. You're going to be using this formula. Second concentration divided by the first concentration. Since you're finding for iron, it will be raised to the power X is equal to rate, the second rate divided by the first rate. Okay, so for what is worth, make sure if you don't want to do a lot of work, you substitute the numerator to be bigger than the denominator. So in this case, the second concentration is going to be 0.2 because it's greater than 0.1. So I'll have 0.2 divided by 0.1, and this will be raised to the power X is equal to rate 2. So since we got 0.2 as the second concentration, the rate 2 is going to be this one. This will be our second rate, this one here. The first one is going to be 1.2 times 10 raised to the power what? 3. When we divide, we're going to get 2 raised to the power x. This side will get 2, and our final answer is actually going to give us 1. So it's actually very simple. Let's find for chlorine dioxide. The same thing. I'm not going to use the formula, but you can use the formula if you want. I'll look at chlorine. So when you're looking at chlorine, you're going to find where this guy is constant. You have this one, and this one is not changing. So you are referring to this one and this one. Now, according to what we can see here, okay, so we'll come to the concentration of chlorine dioxide. We can see that here we have 0.01. Then this one is 0.04. So for them to move from 0.01 to 0.04, they actually multiplied by what? By 4. The concentration quadruple. What about here? We can see that we have 1.2, and this one is 4.8. So for you to reach 4.8, then actually what are you doing? You are multiplying by 4. So this one is multiplied by 4. Even this one is multiplied by 4. The same thing is happening. So we can say that y is going to be equal to what? 1. Because the same thing which is happening to the concentration is the same thing which is happening to the rate. So therefore the rate law will be given by K, then ion raised to the power 1, and the concentration of chlorine dioxide raised to the power 1. Okay, so we are done with the first question. This is what we do. Let's go to the next one. Okay, so this is our next. Okay, so this is our next example. It's actually simple. We're going to use the same techniques we used for the last example that we just did. Okay, so the question is saying the reaction of nitric oxide with hydrogen at 1280 degrees Celsius is this is the reaction that we have. From the following data collected at this temperature, determine the rate law and calculate the rate constant. Okay, so what are we supposed to do here? First of all, we're supposed to write down how the rate law is going to be. In this case, we don't have iron, we have nitrogen monoxide raised to the power x and hydrogen, this will be raised to the power y. Okay, so the aim is just to find the order of reaction and we are done with the question. Okay, so I'll start by finding the order of reaction of nitrogen monoxide. It's actually very simple. Let's dive into it. Look at the concentration of hydrogen. Where is it constant? We can see that from this one and this one, hydrogen is constant. So you're going to use this guy and this guy, this rate and this rate. Okay, so what are we supposed to do here? I'll use the formula. We know that we're supposed to get the bigger one divided by the smaller one. This one is bigger, it's raised to the power negative 2. This one is raised to the power negative 3. Okay, so you're going to say this formula is very simple. Use it wisely. In case where you are doubting yourself, make sure you write down the formula. No matter how good you are, make sure you just write down the formula. Okay, so the second concentration, I'll make sure it is big. That is 1.0 times 10 raised to the power negative 2 divided by 5 times 10 raised to the power negative 3. Then this is going to be in bracket raised to the power x. The rates I have this side 5 times 10 raised to the power negative 5. Then this one is 1.3 times 10 raised to the power negative 5. Okay, so when we divide this side, we're going to have 2x. Then when we divide this side, okay, so this is what you should get. Then what do you do next? This should be a whole number, so you're going to see rounding off is give us 4. Then what are you going to do here? 4 is actually the same as 2 raised to the power 2. So the value of x is actually going to give us what? 2. Okay, so for nitrogen monoxide, the order of reaction is 2. You go to the next one. Okay, the second one. That is, we're trying to find the order of reaction of hydrogen. What do you do? First of all, you're going to look at where the concentration of nitrogen monoxide is constant. We can see that this one and this one, they are constant. It's not changing. Then what are you going to do next? Then you come back to this guy. So this is what we have. We're going to focus on this. Okay, without using the formula, we're trying to find the value of y. We can see that from 2 times 10 raised to the power negative 3 to 4 times 10 raised to the power negative 3, we are doubling. It is increasing by multiple of 4. Okay, so we know that this guy, the concentration is increasing by multiple of 4. What about this one? For them to get 1.0 times 10 raised to the power negative 4, they multiplied this guy by 2 as well. So the same thing which is happening to the concentration is the same thing which is happening to the rate of reaction. So we can definitely conclude that this is first order of reaction. So the value of y is 1. Okay, by doing so, we're done with the rate law. What's the next thing? We've been taught to find to calculate the rate constant, the value of k. So from this expression, we're just going to make it the subject. It's going to give us rate divided by the concentration of nitrogen monoxide raised to the power 2 and hydrogen. This is just raised to the power 1, so you can write it the same way it is. Okay, so you can pick if you want, you can choose the experiment 1, experiment 2, experiment 3. You don't usually get the same value, but the values you're going to be getting, they will be very much closer. If you use the second experiment, you get 2.6 in this case times something, and when you use the first experiment, you're going to get 2.5. So the second one, the third one is going to be 2.7. So the values, they tend to be precise. Okay, so I'm going to get the first box and let's see what we're going to get. Okay, so after you're done substituting, you should get 2.5 times 10 raised to the power 2. Now talking about the constant, and we said it as units. In this case, what are the unit's going to be. So it's just going to be this one here. Now let me explain. We said the units of k is given by m 1 minus n in seconds raised to the power of -1. Now in this case, the order of reaction is what? Is it 2? The overall is 3. That's where you're supposed to add 2 plus 1. And the overall is going to give you 3. When you substitute 3, you end up getting this. Okay, so by doing so, the Bantu, you're done with this question. Let's go to the next one. Okay, so we are on example 13.3. This one is also simple. The question is saying the conversion of cyclopropane to propene in a gas phase is a first order reaction with a rate constant of 6.7 times 10 raised to the power -4 at 510 degrees Celsius. Okay, so the first question is saying if the initial concentration of cyclopropane is 0.25, what is the concentration after 9.8 minutes? Okay, so the value of k is in seconds, so it's supposed to convert this guy to seconds. Do you still remember how to do so? 9.8 minutes is equal to how many seconds? Now we don't know. What about 1 minute? How many seconds? Do you still remember, or you have forgotten? Okay, so for those who have forgotten, my dear, it is 60 seconds. And when you punch this on your calculator, you should get 588. Okay. Then we go on solving the question. Since it is first order of reaction, we say that the first order of reaction we're supposed to put it in. If you don't remember, this was negative. Do you remember the slope? It was going down. Initial concentration. Okay, so we're looking for this guy. The final concentration. What is it going to be? So just substitute. The value of k is 6.7 multiplied by 10 raised to the power -4. Then time is 5, 8, 8.ln. The initial concentration is 0.25. Okay, so punch this on your calculator and see what we're going to get. Very simple. I think the calculator is doing a lot of work compared to us. Okay, so you should get -1.78025. Now, you are looking for the concentration, not the natural log of concentration. No. So what do? This is same as log of what? E. So the E will go this side. I will make everything which is this side become the power, and the log is going to disappear. So we're gonna have the exponent of -1.78. When you punch this on your calculator, what are you getting? Okay, so you should get 1.69 times 10 raised to the power -1 seconds. Okay, so we're done with the first one. Let's go to the next one. How long will it take for the concentration of cyclopropane to decrease from initial concentration being this, then the final concentration being that? Okay, so the same things that we did be the same thing that we're going to do, the same formula, but what we're going to make the subject will be different. So this is the guy. Not complicated, very simple. So I'm going to make t the subject, the time, since you're looking for the time. So it's going to cross the equal sign and it will become positive. This one also crosses the equal sign. It will become what? Negative. This one is initial concentration. Then you divide by k. Then you substitute your units, the numbers. So we know that the initial concentration is 0.2. The final concentration is 0.15 divided by the value of k, which is 6.7 times 10 raised to the power negative 4. Typing this on your calculator, you should get, so you should get 7.62 times 10 raised to the power 2 seconds. Okay, so we are done with this question. So you are seeing, when you know the formula, any question they are going to ask you concerning chemical kinetics, I'm sure you will be nailing it. It becomes very simple when you know the formulas for the zero order of reaction, first order of reaction, even the second order of reaction. Actually, it becomes very simple and you're going to be enjoying. Now this one, actually kind of trick. A lot of people make mistakes. The final concentration is the concentration which remains, not which is used up, which remains. Keep in mind. So look, how long will it take to convert 70? Will it take to convert 74% of the starting material? What does this mean? This means that 74% is going to be used from the 100%. The initial concentration, when you're talking about percentage, the initial concentration, it is always 100%. Then from the 100%, we convert or we use up 74%. So what you're going to have as the final is not going to be 74. That's not going to be the one which is remaining. So it will be 100 minus 74. So keep in mind, this is what we do, and you should get 26. We made time to be the subject was divided by the value of k power. The same thing. You're going to substitute. So you're wondering, what am I going to substitute? The percentage. So here it will be 100% minus 26 divided by the value of k, which we all know. So when you divide, you should get, okay. We are done with this question. Very simple. You should be smiling. These things, they are very simple. Just understand the formulas, please. So try to solve this question 4a. It's also simple, just the same concept. I'll solve B. For the reaction, it is balanced 2A plus 4B producing 6C plus 5T. If the rate of A is 25, find the rate of T. Okay, so we talked about this. Now, how do you go about it again? I talked about a situation where you've been given the rate of one reactant or product. In this case, it's A. So, we're going to focus on A and D. A and D. What are you going to say? You'll say 2, that is the coefficient of A, then rate D is equal to 5 rate A. You are finding the rate of T, so you're going to make D the subject by dividing by 2, which is going to be 5 divided by 2 rate of A. Then when you substitute rate of A, which is 25, what are you going to get? Okay, so you should get 62.5 molar per second. Very simple. What about this one? The reaction 2A producing B is second order reaction. Rate constant 51 and it's in minutes. Okay, so what I will be doing here, the time that I will be finding should also be in minutes. I don't want to convert this to waste my time. So I'm just going to use it the same way it's in minutes. Starting with concentration of A being this 0.0092. How long will it take for the concentration to reach 3.7 times 10 raised to the power negative 3? Okay, so we're talking about the second order reaction. The formula was okay, so we're just going to making T the subject, and this one crosses the equal sign. It will be 1 over the final concentration minus the initial concentration. And there's Km, and I divide by K. Okay, so that's the formula, just matter of substituting. The final concentration is 3.7 times 10 raised to the power negative 3 minus the initial concentration 0.0092 divided by the value of K, which is 51. What are we getting? We should get 3.17 minutes. Very simple. Just using the formula, everything becomes simple. Calculate the half-life. Some of you have forgotten already, but yeah, it will take time. Just make sure you're using the formulas. Okay, so a half-life of second order, we said it depends on the initial concentration. So I'm just going to substitute and I'm done. We substitute the value of K, which is 51. The initial concentration is 0.0092. What are you getting? So you should get 2.13 minutes. There, we are done. This is exactly how questions, how they are going to be. Very simple. Look at this one. Find the units of rate constant of K for a reaction that is third order of reaction. Can you fail to find this one? You fail to find the units. Sure. We said that the units is m1 minus n raised to the power -1 for the seconds. Now since it is a third order of reaction, while we are saying n, we are going to substitute 3. That's going to give us -2 seconds. Very simple. Look at the next question. Which of the following straight line plots corresponds to a first order of reaction? You even take your time here. The first order of reaction, we know that the formula got ln. So this one and this one. Now between the two, we said the slope is supposed to be positive or negative. Remember, it was going down like this, so it was negative. The correct answer is D. The questions, they are very simple. Okay, so the bab could have bantu bamanaka ba promoter. Make sure you go through the question, try to solve just by yourselves. Understand how to use the formula, how to find the order of reaction, and how to use the formulas for the first, 0, and the second order of reaction. Make sure you subscribe, like if you like the video, and also comment. Thank you very much for watching.